Assalamualaikum warahmatullahi wabarakatuh. My name is Aldiansyah from Electric System State of Polytechnic Negeri Malang. Today, I will presentation about instrumentation in 150 kilovolt substation automated system or SAS with dispatcher configuration. Okay, before we talk about our main topic today, I will explain to you about what is the substation and what components are included at the substation. Substation is an installation consisting of electrical equipment that function to transfer electricity from different voltage, measuring, monitoring, securing the electric power system, and regulating electrical power. The next is a substation function. This consists of number one is change one high voltage electric power to another high voltage or medium voltage. Second is measurement, supervision, operation and regulation of securing the electric power system. The third is power setting to other substation through high voltage and distribution substation via medium voltage device. So we go to our main topic today is a substation automation system. Substation automation system is a computerized substation system equipped with an EID by control unit or BCU, EID protection, server, gateway, and local XMI with an abbreviation of the substation automation system, which is a computerized substation system equipped with an EID by control unit or PCU, EID protection, server, gateway, and local HMI with automatic installation maneuverability using the standard EIC protocol. SAS or substation automation is divided into by level, station level, and process level. By level is the primary equipment in the field up to the interface panel by control unit or PCU, and EID protection at the substation. The station level is secondary equipment consisting of server, gateway, local HMI, and supporting peripherals. Process level it consists of all the switchgear devices which are hardware using copper cables and use fiber optic cables to connect the bi-level EID. EID used for control and protection automatic. Automatic substation monitoring and control via intelligent electronic device or EID and a communication network consists and SAS. Through centrally located server and workstation, and SAS use the functional capability of EID to implement automation, protection, metering, control, and monitoring. It's designed to facilitate control local from within the substation and remotely from utility load dispatch center or load control center. Is feature one show as a simple block diagram for a transmission SAS. So next is SAS function. For the first one is control function. The control in question is the control of primary equipment, such as PMT or circuit breaker, and PMS or disconnecting switch or DS. Second is function monitoring. Monitoring here is intended to display the equipment status of the substation, interference alarm, and position of the power transformer tab. Sorry. Third is measurement function. Measurements are made of current, voltage, real power, reactive power, complex power, and power factor. And the last is automatic recording function. Recording is done in the form of recording event, recording of nuisance condition, and recording trending all measure quantities and function of sending SCADA to control center. It's a substation automation system level. For the first one is a by level. A by component by comprises of circuit breaker and associated isolator, earth switch, and instrument transformer. At the by level, the AID provide all bi-level functions such as control or command output, monitoring, and protection. The EID are directly connected to switchgear without any need for additional interposing or transducer. Each by-control EID is independent of the other, and its function is not affected by any faults occurring in any of the other by-control units of this station. The second is local area network. It's the communication link from the bay level to station level. Use a single ring configuration. An MPU EIT that requires teleportation is required to use link a spirit communication that is separate from the SAS data communication link. Ethernet switch for 150, 150 kilovolt system with one switch for panel installed. So the third is station level. The station levels contain the station oriented function which cannot be released at by level. Example or alarm list or event list relate to the entire substation. Gateway for the communication with remote control center. A dedicated master clock for synchronization of the entire system shall be provided. Station level consists of several devices that function to acquire, process, remote control, display information, and store data. The station level uh, consists of XMI and server. And on the server is divided again into two parts. There is a database server and gateway server. For each MI, this XMI function to perform the process of switching, monitoring data, recording the sequence of events, printing, application development, or engineering function, such maintenance and data analysis. The switching process of XMI can be done if in a local general position. Standard XMI display on SAS consists of, for the number one is system overview, overall single line diagram, by single line diagram, ACN DC distribution system, event list, alarm list, common alarm, and trending. And for server, the hardened computer with the SCADA application installed that communicate with EID to provide monitoring and control power system. For the database server, is the database or DB server has the main SCADA application software installed. It communicates with the EID in the field to gather data and to send control command. Data consists of real-time, analog values, indication, alarm, control, and set point. Two computers represent their data on the SCADA XMI. Due to the vital importance of the server, the best configuration is to have to them redundant within a master standby hot or cold configuration. So it's a gateway server. The gateway server is responsible for communicating outside of the substation, example to a master station, to manage operation of all substation in a specific geographical area. The SCADA application database is also configured in the gateway server. The main purpose of this machine is to perform as a protocol converter between EIC 61850 and various other protocols used in the substation to the protocol utilized in the master station, primarily EIC 6 on X7 on 51 on 1 and EIC 6 on X7 on 51 on 4. The gateway server has a crucial role. It is vital that another redundant machine be provides as backup. However, but gateway servers always communicate with the field. The master session perform the redundancy by choosing which gateway server to communicate stroke. In the other words, both gateway server are configured in as master, hot or hot. A typical arrangement of gateway server and database server in SAS shown in figure 2. So next is the main component is EID or Intelligent Electronic Device. In power automation, an EID is a smart device that can perform both basic and advanced functions related to protection, automation, monitoring, and control. In an EIC 61850 environment, every EID can communicate independently with SCADA acting as an intelligent interface for field device. In transmission substation, EID include by control units, protection relay, transformer tap changer control module, smart metering device, and EIC 61850 complaint ERO modules to integrate legacy device into the substation automation system. The next is a workstation. Two main workstations are provided for the grid operator to complete routine maintenance and perform operational activities. For the number one of operation workstation, this machine is provided with a graphical user interface connected to the database server. The operator workstation are not connected to field level EID, rather, the EID completely rely on the integrity of the database server for accurate representation of the data. The operator workstation is configured to communicate only with the master database server. Number two, there are engineering workstation. The engineering workstation communicate with all devices available in a substation. The engineering specific role, which is to configure or modify EID setting parameter and substation configuration description. File of all EID present in the substation. It does not perform any SCADA duties. This computer must be highly secured as it can provide access to any EID present in the substation. Next is communication protocol EIC 61850. EIC 61850 is known for fast and reliable system wide distribution of ERO values. This data transfer is based on a publisher, subscriber, and or client server mechanism depending on the selected protocol, which could be either manufacturing message specification or generic object-oriented substation event. Figure 3 is as ESGI2 model for EIC 61X5 and figure 4 show sample data model hierarchy for a EIC 61X5 or complaint EID. The next is SAS visualization. As mentioned, SAS provides overall monitoring and control of substation from the local XMI. The XMI is a graphical representation of the complete substation that collects real-time information from the database server, which takes data from field device and transform them into dynamic graphics, alarm, and event text. The following are notable features that are served by the SAS XMI. Is a point overall single line diagram. The main screen of the XMI shows the single line diagram of each voltage 150 kV. The diagram presents the open or closed status of the equipment. Example circuit breaker, isolator, earth switch, and line or bus potential transformer. It also shows the voltage and frequency of the variable bus and names and number of transformer, incomer, bus section, and bus couple bay. The screens contain other useful information such as voltage level of the transformer by remote substation or circuit names of incoming by. The screens only monitor equipment for control purpose. The user must navigate to the associated by view of the equipment. And this figure is show a portion of sample single line overview screen. So the next is individual by views. This type of screen provides detailed information about the individual base. The number of screens equal the number of bays available in all substation voltage level. This view provides the following information about the bay. Example for the number is measurement of base to base voltage, pass current, active or reactive power, and frequency and power factor. Through second is position of the base selector switch, example of emergency or local BGU and remote. Number third is position of synchronism selector switch and state of synchronization. This information is available only if there is a by supporting synchronism checks feature. And the last is so open or closed status of available switching equipment and interlocking condition satisfied or not for its controllable equipment. Individual bay views also allow the authorized user to initiate commands for the controllable equipment. So next is interlocking screen. The screen is responsible for giving in-depth information regarding the interlocking logic of controllable equipment. It also depicts the real-time information about the interlock in allowed gate and or circuit that facilitate easy identification and marking of the unspecified interlocking condition, blocking the equipment from operating. This type of screen is helpful for the operator during maintenance and switching activities during which they must satisfy certain interlocks before any operation. Mm, its communication screens, Ethernet switches are integrated with database server to provide port up or down status. This screen show information related to the network. So it's a conclusion. Deploying a robust, secure, and reliable SaaS requires understanding and following various aspects of engineering and design, identify and explaining in this topic. The SAS or Substation Automate System built on EIC 61X5 on base protocol with a diligently engineered, secure, highly available PRP-based network is the key to implementing the smart grid concept, handling the various properties of different protocols with proper knowledge and best known methods ensure and optimized SaaS capable of providing an efficient platform for automation, control, and monitoring. And thank you for your attention. Sorry if there is a wrong word or misspell or wrong about my opinions. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.